ch11 in Doctor's problem 1121. It says for this circuit determine a mathematical expression for the current IL and voltage VL after the closing of the switch. So when this switch closes, this starts off as an open circuit. It finishes as a short circuit. So the first thing you do is calculate tau. Tau equals L over R. In this case, it equals 4.7 millihenries over 2K. Why 2K, you might ask? Why 2K? Because this current is only going through this leg. This is IL, which is what we're looking for. This is the current going through this leg. None of that portion of IL goes through this leg. So we don't have to count R2 in tau in the storage phase. This is the first phase. So the storage equation is this, turns into this. This is the final expression right here. V sub L, this is the storage equation. And then you just plug in the numbers for this. Part B, it says repeat part A if the switch is open to t equal 1 microsecond. Well, we found tau to be 2.35 microseconds. So they want us to close the switch and then open it up right away before this reaches its 5 time constant. So what you have to do is calculate the final current of the storage phase, which would be putting in that 1 microsecond when you open the switch back up. When you open the switch back up, then the current is still going this way, but now it's going through R1 and R2. And then when you plug in that number to this equation up here, you get this 2.08 milliamps. When you put in 1 microsecond in for little t using the same tau. Then you have to figure out what tau prime is, which would be for the release phase. When this is releasing current through this loop with this switch back open, tau prime equals L divided by R1 plus R2 equals this, 392 nanoseconds. So then this is the expression for IL in the release phase. This 2.08 milliamps, which came from here, times E to the minus T divided by 392 nanoseconds. And then to figure out what V sub L is, use this formula, which we figured out here, put in the 1 microsecond for T, and you get 7.84 volts. That was the voltage across V sub L when the switch was moved back into the open situation. And then a T equals 0 plus after the switch moved, V sub L equals that current times the 12K, which is R1 plus R2 equals minus 24.96. V sub L equals minus 24.96 volts times E to the minus T divided by 392 nanoseconds. And 5 tau prime is 1.96 microseconds. So then in the last part it says sketch the waveforms of part A and B on the same set of axes. So over here, I sub L during the storage phase climbs from 0 up to here at 1 microsecond. It was 2.08 milliamps, and then it decays down towards the release phase at 1.96 microseconds, which is 5 tau prime, for a total of 2.35 microseconds here. And then for V sub L, they didn't write it here, but that's what this is. It starts off at 12 volts, which was the initial voltage. And then it decays down to 1 microsecond and then instantaneously goes negative to the minus 24.96 volts that we calculated when the switch was thrown back open, and then it decays down to 0 over 1.96 microseconds, which is 5 tau prime.